Okay, Team 3, I'm going to show you the data that I've analyzed so far. It's gotten kind of complicated. For exposure time of a little less than 1 second, turns out the images are not saturated. And by the way, these COJ, that is a code telling us these images are from the Siding Springs, Australia Observatory. What I found is the aperture 3 is inconsistent in its measurements, and so we're not going to use those. So for everything, all the analysis I've done, we're using aperture 2, which it shows right here, and we have the arc length and the position angle. And so what I've done, and then this is information from the FITS header, and it gives us the pixel scale that we can use. In any case, what I've done is for all the different sets of data, and you can look at the file numbers, file 355 there, and 356, and 357. I measured them all several times, and then took out all the ones that were the 3. So down below here, and here's about a half-second image as well. So the data analysis is shown here. I got all of the aperture 2s. I took the average of the arc length in minutes and the position angle. Okay, and then this is image 356. I found the average of those there. Image 357, 358, 359. And then I put all of those averages right here. Okay, and the average separation, which is, let's see, so this, I just multiplied these arc minutes times 60 to get it into arc seconds, because that's how it's reported in the literature. So here's the image number, here's the average separation, here's the average of those averages right there. Now the position angle is odd. The camera on that telescope is turned in about 180 degrees, I think. And so if we add 180 degrees, and we might have to look at this more carefully, then we get close to the reported values for the position angle. Okay, then, so those were the shorter images. Now for the 3.24 second images, or 3.284, these are taken at Tenerife. That's what this TFN, Tenerife, Spain. That's where these images are taken from, and these were longer exposures. But again, I was able to do the measurements with the aperture of 2, and we get a position angle. And this one I didn't have to change it, so the camera must be angled correctly in these ones, because when it just measures the position angle and it matches the literature values. Again, I multiplied the separation that's given in arc minutes times 60 to convert it to arc seconds. And I've done that for a couple of different ones. Again, it's inconsistent with aperture 3, so I only used aperture 2. So this is an average from the aperture 2 ones. You can see that if you click on this up here, it shows you it's D141 through D145. So those are these 5 images. It's the average of those multiplied by 60. And then here's our position angle. And so I'm going to do 1 or 2 more images, but that's how you analyze, or that's how you understand this spreadsheet. So I've tried to make it clear what our actual numbers are. And we can write about how the different exposure times that we tried and the different telescopes are all giving us roughly the same data. 6.07 is pretty darn close to 5.94, and 356 versus 357 for position angle, and 355. It's all in the same range. In any case, that's how I'm analyzing this data, and I will explain it in the meeting tomorrow.